In this video and several future videos, we're going to look at finding the properties of a function from a graph. Specifically, we're going to start with domain and range. So if you'll recall from Algebra 2, the domain is all the values for which the function is defined, which means the values along the x-axis which correspond to one or more points on the graph. We're going to begin writing our domains and ranges in interval notation. So taking a look at the graph we have, we can see that this graph goes from this point here, which has an x value of -8, over to this point here, which has an x value of +8. As we move along this function this way, we can see that we're going to hit all of these x values here. Continuing to trace this graph here, we're hitting all of these x values here. So we do this next section of the graph, we're hitting all of the x values in this region here. And then this section of the graph corresponds to these final x values here. So what we can look at is what we've highlighted along the x-axis is starting at -8 and going over to +8. Those on the graph are both closed in circles, so we're going to include those values. So we would say our domain, which we're going to note with a capital D, is all numbers from -8 to +8. We're including both of those, so we're going to use the square brackets. Similarly, when we talk about range, the range is all the values that result from evaluating this relation or function. It's going to be the values along the y-axis that correspond to one or more points on the graph. And again, we're going to write those in interval notation. So if we go similarly from here, moving from bottom to top, this is the first point that we see here, which corresponds to a y value of -8. And as we continue along the function this way, we're up to this point here, which corresponds to this y value of 9. If we look at these other sections of the graph, we've already covered all of these y values and all of these y values. So going back to our y-axis, we can see that our shaded region here goes from -8 to +9. So again, writing that in interval notation, we're going to use capital R for range, and we're going from -8 to +9. Again, we're including both of those points because they're closed circles on the graph, so we're going to use the square brackets. Looking at a couple more examples here. On this first one, we have a line. This graph is going to continue going up forever and down forever. So if we think about the domain then, we're going to the left forever. We're hitting all of these points along the x-axis, and then we're going to go to the right forever. So my domain, is going to be all real numbers. My range, similarly, this graph is going down forever, and we're hitting all of these y values until we're going up forever. So my range is also all real numbers. The second graph we have here is a parabola. As indicated on the graph, we're going up forever on the left side and up forever on the right side. So from the left side, I'm going forever to the left, I'm hitting all of these values in between, and then we're going forever to the right. So my domain is all real numbers. My range, my graph is not going down forever. My graph starts here, which corresponds to a y value of the -6, and then my graph goes up forever. So my range values start at -6 and go to +infinity. We're including the -6 because that point exists and it has that y value. Couple more examples here. We want to graph these on our calculator. Remember, at this point, we're finding domain and range from the graph, so if you're just given an equation, you're going to graph it on your calculator. So graphing the square root of x - 4 gives us this graph. We have to kind of think about what's happening on our graph and are things going forever. It's hard to tell on your graph. You can try to zoom in and out and get a sense of that if it helps. So this graph starts here at this point 4, 0, and then it curves up and goes to the right forever. So if we think about our domain, we're not going to the left forever. My graph starts here, moving from left to right, and then continues forever going to the right. So my graph starts at this point 4, so x equals 4, and we're going to the right forever. This point exists, so we're going to put the square bracket on the 4. For the range, my graph does not go down forever. If I kind of go from the bottom to the top, the first place that my graph exists is here, starting at 0, and then it is going up forever, very slowly, but it is going to go up forever. So my range starts at the point 0, including the 0, and then going to infinity. And then on our graph over here, g of x, negative, absolute value, x - 3, and then +5. So this graph, again, is going to the left forever and the right forever, no breaks in between. So I am covering all of the values along the x-axis, so my domain, again, is all real numbers. This graph does go down forever, so covers all of the numbers going to negative infinity, and then all of these values coming up until we stop here, which corresponds to a y value of 5. So my range is from negative infinity to positive 5.